Here we go. All right. So I'm looking back at section 5.2 again. This is but I'm doing it to just kind of refresh your memory and to make sure that we get two things differentiated really, really well. So section 5.2 is all about adding and subtracting polynomials, we said. So I'm going to skip through a good many of the slides and kind of hit the highlights of these so that I don't wind up just treading water. All right. A polynomial is composed of terms. A term has a coefficient, a variable, and a power. All right. We define like terms. You can basically look at them and see they're like terms. But I always like to reiterate this. This and that are like terms. A squared and A squared are like terms because you have A squared and A squared. If you just say it out loud, you can tell they're like terms. They sound the same. A squared and A cubed are different. They're unlike terms. All right. We literally cannot add those together. If I do the operation of addition, it doesn't work. I can't do the operation of addition between those two terms. Neither can I do the operation of subtraction between these two terms. So W and W squared are two different terms. The operation of subtraction doesn't work. We can't do the operation of subtraction. All right. Now, we haven't talked about multiplying and dividing them, but basically just be aware that if we can only add and subtract the operation of addition, the operation of subtraction between like terms. All right. I'm not going to belabor that point too much. All right. Combining like terms is basically a term. So when we say combining like terms, we mean adding and subtracting. Combining like terms does not refer to multiplying. Combining like terms only refers to adding and subtracting. All right. Now, I'm just saying that because you might think, well, combining, I can combine stuff in a lot of different ways. I could do like that. And like I could, whatever. But combining like terms only refers to adding and subtracting. That's the nomenclature we use. All right. When you combine like terms, you basically add and subtract the numbers out in front, the coefficients. The variable and the power stay the same. So 4x plus 3x gives us 7x, not 7x squared, 7x. So just notice the variable part stayed the same. We didn't change it. We didn't do anything weird with that. 4 apples plus 3 apples is 7 apples. All right. Then we looked at some examples of, okay, here what you can add, here what you subtract. 6x squared minus 5x squared gives you 1x squared. That's just something you kind of have to be aware of, that again, the x squared doesn't change. All right. Then we looked at ones you couldn't add together or subtract. 9x plus 7x squared. As much as we want to, we literally cannot put together 9x and 7x squared. We can't. So the temptation is to go, well, 9 plus 7 is 16. Then I have 1x and 2x's. That makes what? 3 x's? So 16x cubed. Got it. No, that's not how that works. We can't add them together. They are unlike terms. So the operation of addition does not work. We're about to get into multiplication, but I will explain the difference. But just realize, if we have the operation of addition or the operation of subtraction, we literally cannot do that. Okay. I worked through some examples of these. You use stacking. I use underlining. they're all really good ways. You could circle them. You could put circles around some things and triangles around some things and rectangles around some things. You color code it even. You can make some of them red and some of them blue and some of them green or whatever. Do whatever it takes to differentiate all your different terms. So this term and that term need to be the same color. This term and that term need to be the same color or have underlines that are the same. Yeah. That's really a practice makes perfect kind of thing. Also, you can stack them. I sometimes like to stack them on top of each other, like terms. That also works. So there's a whole bunch of ways to do it. Pick a good way. Cool. I did one subtracting example. The main thing was make sure that you multiply that minus there by everything inside the parentheses. Basically, it's going to make everything the opposite sign. So a positive 5 becomes a negative 5, a negative 3 becomes a positive 3, a positive 2 becomes a negative 2. So, yeah. 1 second, let me make sure my phone didn't go off. That's better. All right, cool. Distributive property, I think we went over that already. This is just a reminder. When you distribute, you gotta make sure and multiply whatever is on the outside, but everything on the inside. So distributing is the multiplying part. Combined like terms is the adding and subtracting part. Sorry. All right, cool. So that's what we went over just the other day. 5.2. 5.3 is the last section we're going to have on the test. All right, I'm gonna go through it and make sure that we keep things separated out. So if you remember, when we added fractions together, and when we did I put it in there? Right in there. So that recaps what we just did. I'm not going to recap that. That's just a recap of it. Did that? Here we are. Here's a slide. So before we talked about adding or subtracting like terms. And we said you can't add or subtract unlike terms. But we didn't say anything about multiplying or dividing them. All right? So I want you to remember that most of the time in math, adding, subtracting is usually really different than multiplying and dividing. Think about this, right? If I add two fractions together, what do? Well, I get a common denominator, and I have to multiply both the fractions by some number, and then I get some totally different fractions, and then I can do the adding part and stuff. If I'm multiplying two fractions together, I don't have to do any of that stuff. Like, it's super easy. It's like I basically just multiply the top numbers and the bottom numbers. Boom, done. If adding was that easy, it'd be great. But adding isn't that easy, so we have to do all this other stuff, right? That's just how the math works out, right? But so adding fractions and multiplying fractions are totally different. They're two totally different processes. So we have to kind of remember that. Okay, if I add two fractions together, that's one kind of thing. But if I multiply two fractions together, that's a whole other kind of thing. All right, or even sign rules, right? If I add two negatives together, what do I get? I get a negative. All right, but if I multiply two negatives together, I don't get a negative, I get a positive. And if I take a negative plus a positive, well, that could be maybe a positive, maybe a negative. I have to think about it a little bit. It's like I have to kind of think about which one's bigger and all that kind of stuff. But if I multiply a negative times a positive, it's always a negative. Like it's always a negative. I don't have to think about it really. So it's like totally different. I have to, if I look at two numbers and go, okay, I'm adding these numbers together. How do I add two numbers together? Okay, I do these rules. But if I'm multiplying two numbers together, that's a totally different set of rules. So I have to make sure and go, okay, this is adding, this is multiplying. They're totally different. In the same way, the rules for multiplying terms together are completely different. They're totally different than adding them together. So we have to keep that in mind. In the same way that fractions and sign rules and all that stuff are totally different if you're adding and multiplying, you have to think about that kind of stuff. The rules for adding together two terms are totally different than the rules for multiplying two terms. All right, now I'm going to tell you the main differences just right off the bat, and then I'll show you the main differences. Number one, you can totally multiply unlike terms. You can't add them ever, but you can multiply them for days. Secondly, when you multiply two terms, it's going to be it's not going to be the same. It's not going to be as, you're not going to keep the same power. So like I had 4x plus 3x gives me 7x, or 6x squared minus 5x squared gives me 1x squared. See, notice the squared doesn't change. When you multiply terms together, they will change. So those are the two main differences when we talk about multiplying terms. So multiplying terms. How do we multiply terms? So to explain this, let's just think about how exponents work, and then let's just kind of, put it together, right? All right, 10 to the 5. I've got 10 to the 5. Well, 10 to the 5 is 10 times 10 times 10 times 10 times 10. That's how exponents work. 10 to the 5 is 10 times 10 times 10 times 10 times 10, right? 10 to the 3 is 10 times 10 times 10. Okay, what else is new? All right, well, okay, what's your point? Well, here's my point. I'm going to take 10 to the 5 and multiply it by 10 to the 3. So I'm multiplying these two terms. So if I wrote these all together in a line, it would be 10 times 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 10. That makes sense, because 10 to the 5 is this stuff, 10 to the 3 is this stuff. But if you think about it, basically, that's just, you wrote 10 1, 2, 3, 4, 5, 6, 7, 8 times. I mean, so really that's just 10 to the 8. Well, that's interesting. 5 plus 3 equals 8. Or let's take, for example, 2 cubed times 2 to the 4th. So I have 2 times 2 times 2, that's 2 to the 3. And 2 times 2 times 2 times 2, that's 2 to the 4. Well, that's just 1, 2, 3, 4, 5, 6, 7 2s. That's just 2 to the 7th. So really, if you think about it, I'm just taking 3 2s and 4 2s and making 7 2s, which is 2 to the 7th. So that's essentially what you're doing. Is the simplest way to think about it is when you're multiplying terms, you're basically just saying, okay, I got 2 x's over here and 3 x's over here. How many x's does that make? 5. So x to the 2 times x to the 3 is x to the 5, because I have 5 x's. All right, so sometimes I'll ask you, how many x's do we have here, or how many a's do we have here? And you're gonna, and your first thought's gonna be 1, because you'll see one letter A. But it's really important to go, okay, how many a's do I have right here? 2. I have 2 a's. Because I'm a math major, I didn't feel like writing it out because I'm not an English major. I don't want to write a bunch of stuff. So that's 2 a's essentially. All right, cool. So how do you multiply terms together? Well, if you think about it, it makes sense. I have 4 times 2 is 8. I have 2 a's here, 5 a's there. I got 7 a's, 8 is 7. Multiply numbers, add the powers. That's it. Super easy. Cool. All right. So let's say I need to multiply something. So I want to multiply negative 2x times all of this. Okay. Look at my annotate thingy. Here we go. So I need to distribute. Like so. And then go step by step. Negative 2 times 3 is negative 6. I have 2 x's here and 2 x's there. How many x's do I have? 4. X to the 4. I have negative 2x squared times minus 7x. So a negative times a negative makes a positive. So a positive 14. 2 times 7 is 14. I have 2 here and 1 there. That makes 3. X to the 3. I have negative 2x times positive 10. A negative times a positive makes a negative or a minus. A 2 times a 10 makes a 20. I got x squared here, x squared there, because there's 2 x's here, no x's there, x to the squared. So voila, like that. The biggest thing with these is all your signs. Your signs are going to make a big difference. If you don't know your signs and you don't have if you don't know your signs, you're going to have a hard time with this. If you know your signs, it'll be pretty easy. The other thing is, if you need to, you can go ahead and write a 1. So let me actually clear that and write that again. Again, you don't have to, but if you want to, you can write a 1 right there, if that helps you. Some students, when they kind of get kind of a brain fog or whatever, and it happens, we all have them, they'll think, oh, that's a 0, because I don't see anything there. Well, that's incorrect. That is, in fact, a 1. Now, again, it's not because people are stupid. It's just that, like, when you're working a whole bunch of problems, what happens is something happens. I don't know what it is. It's a thing that happens when you're at work or at home and you just have a brain fog. All right. So if you need to, go ahead and write that +1 there, if it just helps you to remember. All right. Let me close out this thing here. All right, what I got here. I have 2 examples. Again, I'm gonna go through them 1 or 2 examples. That's what I do. So so you're gonna say negative 9x squared times 2x cubed. Negative 9x squared times minus 5x. Negative 9x squared times plus 4. I'm talking too fast. All right, so negative 9x squared times 2x cubed. Okay, I got negative 9 times 2. That should be a 3. Sorry, that should be a 3 there. I'll edit that. My bad. It's actually supposed to be a 3. I'll go back and edit that. But basically, pretend this is a 3. So if this is a 3, you get negative 9 times 3 is negative 27, x to the 5th. Negative 9x squared times negative 5x gives you plus 45 x to the 3. If you need to, you can the one right there. Now it's easier. 2 plus 1 is 3. And negative 9x squared times plus 4. A negative times a positive is a negative. So negative 36x squared. So that's your final answer. Now, I would love to be able to take all those terms and say negative 27 plus 45 minus 36 and run that all into a calculator and push it all together and make it into one term. I would love to be able to do that. I really would. It would make my life a lot easier if I could put all this together, but I can't. So as much as I want to take all those terms and smush them all together, I can't do it because we have the operations of addition and subtraction. And what's true about the operations of addition and subtraction? What's true about them is you can only combine, you can only add or subtract like terms. Well, let's look at this thing. That's a 5, that's a 3, and that's a 2. Are those like terms or unlike terms? Those are unlike terms. I literally can't add them. And I can't subtract them. So that means that all the stuff I want to do with this thing here, smushing together terms, adding a 5 plus a 3 plus a 2, and making a 10, and then making it into a whatever that number is. I don't know what that number is. I'm not going to calculate it. All the stuff I want to do, can't do it. I should just stop right there. All right, so it's important that you practice these because what you're going to want to do sometimes, if you're not thinking about it, is try to smush all the terms together because you're trying to figure out, because you're trying to make everything a little bit smaller and a little bit smaller and a little bit smaller. But you can't do it. This is the final answer. You cannot do anything else with that. So, it is what it is. That's how it works. All right. This is very similar. Multiply that by that, this by that, you'll get this. Now I would love to be able to go negative 90 minus 80 and get negative 170. That would be great. No. I cannot do that. They are unlike terms. I cannot subtract unlike terms. So this is the final answer. That's it. All right. Cool. What else next? I just did a longer example. It's the same thing. I'm not going to go through it. So let's go ahead. Let's press on, and we'll go to box method and FOIL method. So, all right, we'll do it. All right. FOIL. Sometimes we have what are called special products. One of the special products we use all the time is multiplying two binomials. Now, a binomial has only two terms. So if we look at this situation here, this is a term, that's a term, that's two terms. That also has two terms. Those are two binomials. So they only have two terms. When I say binomial, I mean it has two terms. All right. Like a bicycle has two wheels, a binomial has two terms. All right. We can do two different ways. We can multiply those together two different ways. We can use what's called FOIL, and we can use what's called the box method, or I call it times table. So I'll call it a bunch of different things. Just kind of be aware of all the different things that you can call it. You have a question on your take-home assignment about doing FOIL or the times table. So I call it times table there. I will call the box method in this presentation. They're the same thing. Just figure out what the best way for you to remember it is. All right. Interesting. All right. I'm not sure why that's in there. That's okay. All right, box method. Basically, you put things together in like a little table, or a table, or you can call it a box, or you can call it a times table, whichever you want to call it. And then you're going to multiply across. That's why I call it a times table, because you're making a table and then you're timesing stuff. And I'll show you how I do that real quick. Or you can use FOIL. So let me start by working out this problem right here. So I'm gonna write that on the board first. Okay. What I got? I got red. That will work. Black markers it. Oh, I know I did. Stop share. What am I doing? Here we go. All right, that's glary. So let's a lot. Let me just see where I am. I'm right here. So let me just start here. So weird. Hold up. That's glary for some reason. So let's turn this on and this on and this off. See if that's visible. A little bit of glare. That might be visible, might not. Okay. Yeah, that's better. Okay. So we're gonna use the box method. The way we do it is we basically set up a little box. So here's a box. Like that. You see it's got 4 different things. You may not be able to see what's in the box, but hopefully you can see that it's basically a box that's got 4 squares. Then what you do is you take each of the binomials and you split them into 2 parts. So this x minus 3 has 2 parts. It's got an x and a minus 3. This binomial here has 2 parts. It's got a 4x and a minus 5. 4x minus 5. And you basically go across and you do a times table. So x times 4x gives you 4x squared. So it's not just 4x, and we're not adding here, we're multiplying. So x times 4x is 4x squared. X times minus 5, so x times minus 5 is minus 5x. Minus 3 times 4x, again, I'm doing a times table, kind of like that sort of. I'm just not writing it. Is negative 12x. Negative 3 times negative 5 is positive. 3 times 5 is 15. So kind of see what I'm doing. I'm just basically doing like that. I just go through and I'm filling in all the boxes. So then I write that out. I get 4x squared minus 5x minus 12x plus 15. Now, do I have any like terms? Well, let's see. I've got 4x squared. I've got 5x. I've got 12x. And 15. So I do some like terms. I have these right in the middle. These are like terms. Okay, I can actually do that. Okay, so I got 4x squared minus 17x plus 15. Now, can I do anything else? Let me see. I got x squared. Okay, I got x by itself essentially. Okay. I got a number without an x on it. That means these cannot combine together anymore. That's it. And that's called the box method. I basically just go across. I basically take both my binomials. I split them into their 2 parts, like so. You can see kind of that. You can see that right there. How I split that into 2 parts. Put that into 2 parts. And then I just did a times table, like so. And it's a times table. We know it times being multiplying. That's why I call it a times table, because it's a multiplying table. Not an adding table, not a division table, not a subtracting table. It's a table. So we times it. All right. Now, we can also use FOIL with that one. All right, let me do another example of a times table, actually. So 3x plus 2 times 2x minus 5. I'll do that one. So 3x plus 2, 2x minus 5. All right, I'm going to do a times table again. All right, if I times table that, I basically take the 3x plus 2 and I split it into 3x plus 2. Not rocket science. All right, 2x minus 5. I split it into 2x minus 5. So again, we haven't done any rocket science. Then I multiply. I'm not adding, I'm not subtracting, I am timesing things. It's called a times table. So I'm gonna do it like this. 3x times 2x is 6x to the 2. Because x and x makes how many x's? Makes x squared. All right. 3x times -5 is -15x plus 2 times 2x. I'm just doing that. I get plus 4x plus 2 times -5 gives me -10. All right. So then I go and I write everything out. I've got 6x squared minus 15x plus 4x minus 10. So 6x squared minus 15x plus 4x minus 10. These are like terms. These are unlike terms, so and so forth. Calculator, voila. Cool. That is how we do a times table. So again, pretty simple. The biggest thing is the biggest mistake students make. So let me tell you the biggest mistake. The biggest mistake that they make is right here. This first box. They go 3x times 2x and they say 6x. Because they're using the rules for addition. But this is not addition. This is multiplication. Multiplication is different than addition. We don't have the same rules for multiplication as we have for addition. It's just like fractions. It's just like signs. The rules for multiplication are different. And so when we multiply 3x times 2x, we get 6x squared. So the big mistake that you're going to make probably at the beginning is you're going to keep making that a 6x. It's not a 6x, it's a 6x squared. All right. But eventually you'll stop making that mistake. All right, cool. Let me share screen. All right, the second method we use is called FOIL. And I'm not gonna do it. I'm gonna do this one using FOIL. All right. And I'll actually have to, I'll zoom back out in my screen and stuff. Yeah. All right, let's stop share. All right, we're gonna FOIL this actually. So FOIL stands for first, outer, inner, last. FOIL. First, outer, inner, last. So first, we find the first terms in each of the parentheses. This one and that one. First. So 2x times 4x. Outer. We find the outside term, so we go outside. So if I go outside this thing, or outside this thing, I don't know how my hands are working, but here, if I go outside this thing, then I get this one and that one. The outer limits of it. Inside, well, we take the inside ones. And last. So the only pair we haven't put, it was these last ones, the last one each of these. First, outer, inner, last. So we do that, and we get 8x squared. Why is it squared? Because we're multiplying. Outer, negative 6x. Inner, plus 4x. Notice I put a plus 4x there. Your calculator won't say plus 4. It'll just say 4. But I put a plus 4 because there is a sign associated with it, is a positive sign. So I put a positive 4. Minus 3. All right. Then from there, once you have that, you get 8x squared. I'm in the glare. And out of the glare. You get 8x squared minus 6x plus 4x minus 3. These are like terms here. 8x squared minus 2x minus 3. If I do this with the box method, I'll get the same answer. So either one is good. All right, cool. Is there anything else I need to go over? Let's see. Example number 2. No, that's, yeah. All right, so let me just summarize. Practice makes perfect, all that stuff. If you don't get these problems, you're not gonna know how to do them. So you gotta actually practice these problems and do the homework assignments. But you already know that. You've already heard that, you already know it. All right, let me summarize. Adding versus multiplying. All right, when we add terms, we can only add like terms. All right, when we add terms, the powers stay the same. So 4x plus 3x is 7x. And we can only add like terms. We multiply terms. We can multiply like terms or even unlike terms, assuming if the variables are the same. I just kind of put that in there just as a caveat, but basically we can add like terms and unlike terms. You multiply terms, you add the powers together. So 2x times 4x doesn't make 8x. 2x times 4x makes 8x squared. Because when we multiply, the powers are going to change. All right. This just goes through everything we said. Yeah. Everything we said, everything I just said. Whenever you have parentheses, you have to make sure and distribute. You multiply by everything in the parentheses. Everything in the parentheses. So be careful with that and such. All right. We went over FOIL. We went over box method. Practice them both. Some questions will say, solve this using FOIL method. If it says solve this using FOIL method, you can also use the box method. So don't feel like if you don't get FOIL at all, don't feel like you have to do FOIL. You can also use the box method or the times table. Whichever way will get you the right answer, essentially. Anything else? That might be it. That's it. I'm gonna stop recording now.